Hey everyone, it's Rick Carson, and today we are not at the beautiful Make Believe Studios. We are in Long Beach for the 2025 AES convention. And we are very excited because we are out here to celebrate with our good friend Gary Gottlieb, the president of AES. Metro Kalo, Sontec, and Make Believe have sponsored the presidential meet and greet, which is happening tonight at the Hyatt Regency, and we are very excited. We'll have some footage of that going on, but ultimately what we want to do is go and catch up with all of our friends here on the AES floor, see what everybody's been up to for the past year, see the new products that they're bringing, and maybe we'll get a little bit of rumblings for what's coming up in the future. I'm excited because it's different. It's a different vibe. We are not in New York, which is something that I've become very accustomed to, going up there every October and seeing my friends, and I've gotten into a routine, and I'll say that this is my first time actually staying in downtown Long Beach, and it's very, very nice here. I hope that the show is great. Come join us. We're going to get into it now. We are about to enter the AES exhibit hall, see what's going on. College of Art and Design. Can I steal some of your candy? Is that okay?
You can.
Okay, yeah. Awesome. Thank you. Tell us about your College of Art and Design. Where is it at?
We're in Sarasota, Florida.
Okay.
This is all our students mixing Atmos for their films. This is an Atmos demo of some of our stuff. You're going to take a listen to the headphones.
Oh.
Get a hat if you do.
Yeah. So did you guys mix the Sony commercial? No,
Yes.
No shit. This is very, very cool. And so was the Sony commercial done in Atmos or was it done in 360
No,
VR?
it was done actually in 5.1 about 3 years ago.
Okay.
And then when I took it to the school, we remixed it in the school in Atmos.
So you did it?
Uh-huh.
Oh, awesome.
With our students, yeah.
Nice. My name is Rick.
Hi, Rick. Nick Palladino, Troy Logan.
Nice to meet you. Yeah. Well, I'm going to steal more of your candy. I'm sorry.
Please, go for it, man.
Okay, thank you, man. Hey, Wes.
Hi, guys.
How's it going? I'm Rick.
Rick.
Nice to meet you. You just told me you're Mr. Time Code.
Well, that's what it looks like. 32 by 32 router.
That's this guy over here, right?
Well,
In
no,
Eurorack.
In Eurorack, too.
Eurorack.
Yeah.
Really? No way. So, Colin, tell us what you got going on. You've been, nominated for an SOS award this year.
Yeah.
And which product is that?
That's I believe that's on the MyCamp, which is part of the system I do with. This is the controller,
Okay.
and they all plug together. Because obviously, making a controller for every module, you don't want a controller for every module.
Yes.
So we do a total of four modules now. These three, which is this is the brain, the CPU. This is a 16 by 16 matrix, which you can combine two together to make a 32 by 32.
Yep.
And this is an 8-channel gain and sum,
Okay, perfect.
all controllable from here or by a MIDI.
Okay. So if you have one of the processors, you can control the gain and the gain and sum.
That's
but if you
right.
don't have a processor, you can just do it with a standard MIDI CC control.
No, it all goes through here
Okay.
because this has got the Ethernet MIDI, USB MIDI, and normal, serial MIDI in out.
Yep.
And the display to show you what's going on. And these are triggers so that you can assign what triggers what.
Yes.
And then I added the MyCamp, which is this one. And you can see it's got 48 volt phantom power. It's got a high impedance jack input, polarity, high pass, switchable gain. And you can and then an insert point so you can combine it with something else, like for instance the gain and sum, because the switchable gain is in 16 dB steps.
Yes.
But this you can do a quarter dB steps if you want to. So there's a patch point, there's an envelope, there's a trigger, and a gate.
Okay.
And you can set the trigger level from here.
Okay, very cool.
And the idea, you push this button, it selects this module.
Oh.
So essentially, you push this one, the display comes up for that module.
So how many of these could you have connected to a brain?
15.
15.
Yeah, but nobody would do that.
Yeah, but if you wanted to, you could.
Yeah.
Yeah. Okay, very cool. And so I'm assuming, looking at what we have going on over here at the table, that some of the technology that has made its way into these, awesome Eurorack modules comes from some of these bigger brains.
So essentially, it uses the same processor, the same basic software. The fact that, as I say, I already had the USB MIDI stack.
Yep.
Yeah.
So tell us about this. This XP Relay 64, is this a MIDI controllable patch bay then?
Yep, well, from our own software as well. You have software which gives you either a matrix display, which I can bring up. So you've got a matrix display.
Very cool.
Or you have a path display. And the path is great because when you do the matrix, interlinking things is really complicated. And working out what you've done is also quite complicated.
Yes.
So the matrix is there for people who like matrices and also for me for confirming what you've actually done.
Yes.
And then you can pull from a pallet different things. You could drag and drop.
I was just about to ask, so this pallet over here, is that like your outboard gear then?
So that's the outboard gear. And you can drag and drop, you can bypass.
Yep.
You can select them from a Stream Deck.
Oh, awesome.
That is a film type module. If you're a film person, you know exactly what it is.
Okay.
It's and it's called a PEC Direct. And PEC stands for photoelectric cell, because the technology goes back to, or the ideas go back to when you recorded sound on film as an image rather than as a direct recording on film, right? Before magnetic tape.
Mag stripe or whatever?
Yeah. Well,
before that.
Before you had magnetic tape, the sound was recorded on optical film.
Okay, very cool.
And so that whole technology goes back to then. That's why it's still called a PEC Direct box.
Okay, and this still interacts with that?
Yeah, this plugs into a Pro Tools.
Okay.
And gives them the same ability. And so this is record. The idea was that you would go pre-post, sort of monitor in, out,
Yep.
and then you could just drop it into record by flipping up that one.
Okay, very cool.
We sell only to the States just about,
Yeah.
and it was in a lot of studios, and still is in quite a few. They've still got them running, and
And over here is this?
this is that's a monitor control.
And so is there a brain for this hidden somewhere?
This is actually his own brain. We did it originally for the Xmon, which is this is a Pro Tools piece.
Yep.
Because the Xmon was controlled by the desk, but if you didn't have the desk, you couldn't do anything with the Xmon.
Yep.
So that was, and then we made it interface with the NTP box, which became the MTRX.
Yes.
So it talks to the MTRX. It will emulate a MOM, which is the MTP controller, which you couldn't get after a while. But it also has its own software, so you can do it, program it. One of the problems with the MOM is that you don't have any meters, but this has the meters. But we also made our own analog versions it talks to as well.
Okay, very cool.
And it will even talk to one of these and set up a monitor within a matrix.
Oh, awesome. So, almost everything can talk to each other.
Yeah, not necessarily in the best way, but it will. And the reason we started doing the matrix here was we had a customer who was using an X-Patch and has masses of modules. He said, can I have the same in my Eurorack? Yep. And so that's why we did this. And it was like, as I say, to design a processor for every piece. Yeah. Yep. So I said, I'll make, and they link together on this ribbon cable.
That seems nice. And I'm assuming if they've got to be further down the rack, you can just get a longer ribbon cable, right?
Well, basically you put next to it, you just get a longer ribbon if they're first. But if they're next to each other, it's just plug them in like that. So they don't need any, you don't have individual power going to each.
And they run off the standard Eurorack power. They don't.
Yeah. +5, ±12.
That's awesome.
Yeah.
Great. Well, thank you so much, Colin.
Cheers, Rick. Well, thanks for showing the interest. It's always nice for me when people are interested.
No, I think this is great. I actually have a buddy named Aaron Gum that I'm going to call. Aaron, I'm going to show you these, and I know that you're going to buy them. He's going to love this. So you could go ahead and you could set up stuff in your processor without even being plugged into the rack.
And this talks to this software as well, so you can control it with the same software as you're controlling these.
So you can control not only your Eurorack, but also your whole studio from the Eurorack module. Oh, snapshots, perfect. Oh, yep, cool. So yeah, this is just a little push button, and then this will go back. That works very, very nice, everybody. So if I click there, I can see the modules. I can go back.
When you have modules connected, it recognizes them automatically.
That's awesome. Cool, perfect. Thank you so much.
The OC7 is the best kick drum mic ever invented. It is.
I would like to believe that I started that
did.
with Ryan. Well, we got the microphone and we looked at it. We're like, oh, this is a really cool kick drum microphone. And then we put it up there and we came up to you at AES the next year and we said, yeah, man, that's the best kick drum microphone we've ever heard. And you said, what kick drum microphone? And we said, oh, the OC7. And then you're like, you're using it as a kick mic.
Well, you know what? And I do as well in my studio. So it's very interesting. It's a cool mic because the attack, gives you such a strong impact on the bass drum, and you can still tune it, and it covers with a sound pressure level.
Yeah, see, that's what I love is it doesn't fold, it holds up very, very well. And then also, as you said, the top end, all the other kick drum microphones out there, I have to add top end to them. Where this one, I get to take away top it. You know, it's already loud and proud, and I can pull it back, and then the low end stays, and it's huge sounding. So, I mean, to be real, it hasn't left our kick drum in, since we had it almost 2 years now.
When the only time we did was for the kick drum shootout.
Yeah.
And then we went right back.
Yep. So it's hands down one. These microphones and the 818s have gotten a ton of use at Make Believe. We have
818's just the stand. That's like forever our mono overhead.
Mono drum overhead.
And
yeah.
That
Yep.
818 lives on the Mesa.
Yeah.
And if you use it as a mono overhead, I mean, have you ever played around with the plugin?
So we have tried a little bit, but we haven't done what I would consider in-depth tests, because we talked about making a video about the actual plugin, and if you would like us to, we will.
Because the fun thing is, if you use it as a mono overhead,
yes,
then you can play with the room in the mixdown. And then, because the plugin, what it does basically, you don't have to decide for a pattern while you record.
Okay.
Because you record both capsules.
Yep.
And I mean, you know how pattern gets created, right?
Yeah, absolutely.
Mixing the two capsules.
100%.
And now you can record both capsules separately.
Yes. So do you need that special cable for that?
It's in the box. Yes, you do. Actually, you have here a second XLR output.
Yep.
And on the end of the cable, you have then two XLRs, right?
Yes.
And then you record both capsules. And that way, and that's really cool. I mean, it's because you mentioned the mono overhead. You can even use it as a pseudo mid-side.
Oh, interesting.
With a stereo creator, we have more than one plugin. You have the Polar Pattern Designer.
Okay.
So there you could only change basically the width of the pattern after the event of the recording, which is cool as well, because if you're in a room that gives you some nice reflections, a good drum room, then you can switch it probably to a figure of 8 and listen what it does to your overhead.
Yeah, you can listen to the other side of it. Yep.
Or you can add a little bit of it. So you can really play around with the sound after the event of recording without EQing it, because EQing gives you some phase issues.
Yes.
But with that, it's just a linear, phase linear, playing around with the pattern in the room. So try that. I think you would like it in the mixdown.
Okay, and the easiest way to do that is just to record both those outputs to a stereo track and then insert the plugin as a stereo plugin?
Exactly.
Okay, perfect.
Exactly. You can either use the stereo creator.
Yep.
And that's very interesting because you have then the two capsules. Yep. If you position it a little bit 90 degrees to the source, you can actually use it as a pseudo mid-side recording.
You're talking about putting it up,
Yeah, exactly.
Very cool.
With one mic.
One mic.
So that's pretty cool.
Okay, so we'll definitely go do some tests on that, because we've been loving that microphone. And so, Bern was just telling us that this is the new thing you got going on here. Yep. So the CC8, we haven't tried this microphone yet, but this has been out for a minute, right?
This is out for quite a while. So that is our really high-end pencil mic. Uses our CC8 capsule, CC7, which is again our own design and Vienna made.
So these are made in-house in Vienna.
Everything what you see here is made in Vienna.
That's amazing.
Everything. From the membrane inside the capsule to the microphones, we're making it all in Vienna.
That's awesome. How long would you say that it takes, a capsule like this to be produced?
Basically, I would say it's 2 steps.
Yep.
The one thing is do the membranes. I mean, these are the large membranes. So these are from the 818s and so that's the 1-inch membrane. But you can imagine that the 1/2 inch would look similar but smaller, right?
And this is a gold sputtered capsule?
Gold spotted as well, yeah. So that's the first step. That's made by basically one lady and a few measurement instruments. Yeah. So the membranes get tensed.
Okay.
Yeah, on the rings, and then of course we have laser measurement because you have to have the tension equally over the whole surface. And this needs to dry and this needs to pause before you can then build the membranes into the capsules. And this is done by a second lady in a separate step.
Okay.
Yeah, but so that's our assembly line. It's basically two ladies.
Two ladies. Okay.
Working on these capsules.
How many capsules are you trying to turn out a day?
In a day, I would say it would be roughly 20 capsules.
So do you have 4 ladies, one for the large diaphragm and one for the small diaphragm?
No, we're doing it in badgers.
Okay.
So we basically have 2 specialized ladies. Yeah. Well, we have 3, and they switch because we have other assembly stuff to do, and you have to assemble all the mics, you have to solder, you have to. But basically, we have 3 specialized ladies on capsules, and they would do a batch of smalls, and then when we have enough of these, they would do a batch of the large.
So how many people is it over at Austrian Audio?
In total, we have 50 people.
50?
Yeah.
See, I love hearing stuff like that. You guys are clearly dedicated, and if you wouldn't mind, if we could go back a little bit. I know we're here to talk about this beautiful new microphone, but I love what I know of the story of Austrian Audio, which is that, Harman bought out the AKG factory, right? And you guys...
That's even one step earlier. Basically, when there was Sydney, he is an audiophile. He was an audiophile. He was in the company until the age of 93, I think.
Okay.
And he really was dedicated to create great audio products. And he bought companies around the globe that did great audio stuff. In Vienna, it was AKG. It was Soundcraft in London, Studer in Switzerland, JBL in Americas, Lexicon, DBX. All top brands, all globally among the top 3. But then, when he passed away and the whole thing went a little bit more into a different direction, automotive became a very large part of this group.
Yes.
Even more important than pro audio, significantly large. Then, of course, there was this interest, and I don't know, the whole Harman group was sold to Samsung. I don't know if you know that.
No, I didn't.
So now all the Harman group belongs to Samsung, so the Korean guys, and they are mainly focusing on automotive. Right, and that was the day in 2017 when all the pro companies were closed down. Not only AKG, Soundcraft, DBX, Studer, Lexicon, PSS, all closed down, and all the R&D folks were let go. So we decided to regroup in Vienna, actually on the same furniture, with the same people, and restart the microphone company under the new name Austrian Audio. So that's the history.
So when that happened, were you guys able to acquire some of the equipment that you had already been working on, or did you retool a whole new factory?
Basically, secondly. So basically, we had to redo it from scratch. But yes, we kept all the people, and B, yes, for example, we acquired the whole anechoic chamber, because that's one of the very important and expensive parts to measure and develop new stuff. And then, some measurement stuff we could acquire, because basically the whole group moved out of Austria. There's no Harman employee in Austria anymore. So yes, we took most of that stuff over. But of course, we also had to add new stuff because it's technology moves on.
And you guys are clearly building different products than AKG did.
Well, there is no reason to do the same thing again.
No. And what you guys build it, I feel pro audio is weird, because for as much as people want to believe that they want innovation, everybody wants tradition. They talk about how they want a new guitar, but then they go and buy a 1959 Les Paul, and they do it every day, every year.
I love that you saying that, not me.
And what I love about what you guys do is this feels good and it feels new when I use it. There's a whole new ground to break with them, but you can say, oh, in tradition, this can harken back to a 414. And everyone wants to ask me about this. Does this sound like a 414? And we've done a direct comparison. It does not sound like a 414 to me.
Well, may I ask you which 414s you're comparing it to?
Well, we compared it to a EB with a CK12, and then we also compared it to a BULS. And in my mind, those are the two schools of 414, the bright and the dark. And they kind of went from there, even to the point where AKG at the end of it, they were producing a bright and dark 4414, and they said the TL or whatever was
TL2 and
was for vocals, or it was just bright, And in my mind, this is not as bright as an EB, but that doesn't mean that it doesn't have air. This microphone reminds me more of what I would think people believe a U87 should sound like. And that's
without that extensive mids.
Exactly. Well, that's the thing, because the U87 sounds chalky and mid-rangey and shitty and weird, where this sounds big and warm and smoky, but doesn't have that.
That was the intention. Exactly, that was it. And
Oh, see, I didn't know that, you know?
And if you read our mission statement, right, you will read, yes, we honor tradition, we honor vintage sound, but we have to bring it into a new century.
Absolutely.
And that's why we said we will not do Me Too products. For example, that we added to an 818 a second output, that you can choose the pattern after the event of the recording. That may sound weird, but it helps, it saves you in so many situations. I mean, if you are in your recording room, where you know the room, where you know any reflections, that's fine. But how many recordings are really done in recording studios anymore? You record on live events, you record in rooms where you haven't been before, but you should choose the amount of room you allow into your recording without knowing what you really allow. And now you can choose that after the event of the recording because you can mix the two capsules and hence change the pattern after the event of the recording. So you listen at the down mix, okay, which of the frequency responses of the room were nice, I keep them, but which ones I don't like so much. So in this frequency range, I make it a supercardioid. But for example, in another frequency range, I like the response of the room and I keep it an omni or a figure of 8 because I like the rare side reflections. That's something nobody has done before, right? Yeah. So we try to bring traditional sound into a, let me call it digital workflow, despite there is no digital in the audio path.
No. And you know, when I think of that, just so where my head goes, because, you know, I've seen the plugin and I've messed around. It was just the first day that we got it, though, because traditionally I get something like this. I'm like, oh, let's go to work. Let's try and use it. But what I love about the dual output of this and where my head instantly went and where, you know, I haven't been able to use it, but I know it's going to be perfect when I do, is recording two people on the same microphone. Like when you go to do that duet recording on a video and you put that microphone up and they're both singing in two sides of it and you got the cable coming down and you got the ability to have access to both sides of the capsules after the fact. That is the future. That's the sort of shit that you wish you could do.
Well, actually, with our plugin, you can even automize it in your mixdown. So you can change the balance during the mix and automize it.
Yes. So you can pull, if someone's walking around, stepping back from the microphone, you can pull them down.
And you can correct it.
Yep. See, and that's very cool, and I love that you guys are a forward-thinking company that is steeped in tradition and history, And I love that, what my ears tell me about this stuff is clearly in line with what I think you guys are trying to do.
Thank you very much.
Yeah.
Well, actually, again, that's why I think we can't get rid of our heritage, and we don't want to actually.
No.
Because that's why we have people in the house. I mean, I added it up with more than 400 years in experience, what they do, right? That's great.
Yeah.
But we can't stay there because we are a new company and we want to go into the future rather than looking always back into where we come from. That's great. And that's in our genes and that's in our DNA. But that's what we have anyway. Now let's use that and create new stuff that really fits into a modern production world.
So with the new stuff, tell us about this. What makes this special compared to this besides the polar pattern?
Well, actually, in this case, it is what it is. It's the polar pattern. And it's, if you are into orchestral recordings, you are sometimes particularly needing a very narrow pencil mic. Yes. So, and as we are not doing modular, because, and I'm very open and honest on that, to do a modular pencil version makes you pay for a lot of mechanics that you probably don't need, right? So we create now, next to the cardioid, the super cardioid, especially for string sections, when you're recording in an orchestra, you would need a hypercardioid or super cardioid version. Okay. I mean, you might need an omni as well, and it might happen that we do an omni version of it as well. Yes. Might happen.
Okay, I see where this is going. I have a question. Are you guys intending to do, not to throw back to the legacy of another company here by any means, but when I think of, cardioid, supercardioid, omni microphones, there's always another one from this kit of, you know, microphones that's out there, which is the cardioid with the bass reduced capsule. Are you intending to do anything like that at all?
Actually, thanks for the idea. No, we haven't had that on our roadmap so far.
Yeah, so it's the KM86.
Yeah, yeah.
Actually, one of my favorite microphones out there.
Okay.
And one, I love them because you can usually find them cheaper, like $1,000 cheaper than an 84. But two, you know, because it's cardioid and because the low end is rolled off, it's pretty much just undoes the proximity effect, and you can get it close as shit to stuff, you know, and it's great. I really like that mic.
It doesn't really undo the proximity effect. It just doesn't give you that much low end, so the proximity effect would not be that obvious.
Exactly. Like, you know, the proximity effect is probably exactly the same as the capsule buildup because you can't really get rid of that. It's just, you know, there's less low end in the microphone. So.
Yeah.
But a question, I mean, I'm always open to suggestions, but what for would you use that mainly?
I use it for kick drum.
Okay.
Yeah. It's a very, you know, it's an interesting thing. So if you go and look,
Why would the proximity effect be an issue on the kick drum?
it's just a different sound. You know, when I use, it's, you know,
It's
when
just
I
an
use,
alternative.
when I use the KM84, I feel like it gets weird and I have to go after using EQ. Where when I use this one, it's like a very big punchy sound. And most people don't think of using a microphone like this on the kick drum. But, you know, there's this sound from the 70s, like the Funky Drummer, for example. That's a KM84 on the kick drum. The Jackson 5 stuff, those are KM86s on the kick drum. You know, so for me, this is where I ended up. This is my permanent kick drum microphone. But, you know, that's when I go after using a Neumann for that kick drum sound in particular, I'll use the 80, you know, that 85 because they're fucking $1,000 cheaper than an 84. And I like the way that they sound. This ceramic holder here, instead of using a brass capsule.
Exactly. There are 3 reasons actually for it. If you remember vintage microphones where you have the brass capsules, you bring them from the cold truck into the studio, or a singer is singing with a lot of moisture for a longer time, you experience some of this sizzling noise, like, and that's because brass is an electric leader. So you basically connect the 2 membranes with each other. In ceramic is an isolator, that doesn't happen.
Okay.
B, ceramic is stiffer than brass.
Okay.
So it doesn't change over time. It doesn't corrode, A.
Yep.
Yeah, so it stays as it is for the next 50 years. Secondly, we don't need those 12 or 14 screws to tighten it correctly because ceramic is such a stiff material that we can get the same equal tightening with the 3 screws instead of having then 12 or 14 screws.
Oh, that's awesome. So these 3 screws handle the tensioning.
Yeah.
That's rad. And, you know, you can see here that there's is this a rubber isolator?
Exactly. And at the end of the day, you now have, I mean, this is the single membrane one. So there's no second membrane on this one.
Yes.
So this is basically the one that's coming in the OC80,
Okay.
right? So it's not a dual, it's a single.
Yep.
But in a dual, you would have a second membrane at the rear side. And the big advantage of that design is that we get back to the, let's call it rather vintage capsule design and sound, because we have the same volume, we have the same specific weight. If you look at the other Viennese company and the recent 414s, you would see all the nylon capsules in there.
Yeah.
And the problem there is they're so lightweight that with a loud signal, not only the membrane moves, but the whole capsule moves, which isn't what you want.
No.
You need a certain weight. And brass gives you the weight, but the ceramic gives you the same weight as well. So we really had a lot of experience in the house, because we even brought the 87-year-old Conrad Wolf, who designed the CK12 capsule. And he was on board with designing this capsule.
That's amazing. So, you know, that I just learned something, you know, for the folks at home. So what you're saying is that what's actually important, you know, everybody talks about the brass capsule, and one, you know, it's a striking feature to look at and it looks great compared to the nylon capsule. But what's actually important is the weight that it provides around the capsule.
The specific weight of the material, and hence the weight of the capsule, that it's staying where it needs to stay in a loud environment.
Yes.
And then, of course, all what other things I mentioned, like over time corrosion, over time stability. Because, you know, it's always interesting. I always love to tell this story because people refer to certain mics as unique, great sound. And I was part of the team when the C12 VR was designed.
Okay.
Right? And it was the biggest important thing that it sounds the same as the old vintage C12, right? So what did we do? Listen to microphones. We brought in over the globe 50 C12s from famous producers like Quincy Jones, like Peter Wolf. We had to insure them because the people were afraid of transporting the mics and so on and so forth. And we got 50 vintage mics in and none of them sounded the same. So which one should we now match?
Which one did you go with?
Well, at the end of the day, you had to decide for an average where you thought this was the original, what the people were referring to. But bear in mind, each of these 50 people refers to his mic as the one.
The one, yep.
Yeah. And that's the same with every of our users. And that's what perfectly comes in with what you stated before. We are people who believe we are innovative,
Yep.
but think very vintage.
Yeah,
And then the vintage is even our own sound we got used to.
exactly.
Because we're using that mic since 30 years, and that's the one, and that's how the next one should sound, but it didn't sound in the beginning.
Well, and that's why I think that I gravitate towards your guys' product so much compared to the other. I mean, let's be brutally honest for the people on the internet. People, when you get to a point in this industry, people will send you microphones to try out because they're interested in your opinion, and that's where we got. You wanted to hear what I was, thinking of these microphones, and as soon as I heard them, like, they have never left my workflow. Where there's microphones that I hear and I'm instantly like, oh, that's cool. But a lot of microphones that are made nowadays, they're what I consider trashy in the high end. They do this thing in the high end where they're trying to bring it forward in a way that makes it sound exciting and makes their mic sound vibrant. But what ends up happening is it sounds crunchy to me. And your microphones don't do that. They sound open and airy, but that 3 to 7K range always sounds articulate and delicate, but never overbearing and shitty.
But that's another thing, and I think you're right, And that I mentioned the example before, because at the end of the day, we shouldn't try to redesign stuff people are used to, because you can't, because everybody's used to something different. What we try to do is we try to achieve with experimenting with new materials, but following traditional rules, creating something new that sounds good. Good is a very subjective statement.
Absolutely.
But you mentioned airy. For example, every of our microphones is called OC or OD.
Okay.
Why? Because we try to follow, we call it OAT, OAT, so like open acoustic technology. Why? We all know the perfect microphone would have no housing. The perfect microphone would look like this.
Yes.
Right? No body in a free field. So what we try to do, we try to recreate as good as possible a free field acoustic in every microphone. We talked about these guys, right? It's not only that the capsules are not sitting on top of the electronics like soldered to it, but it's suspended internally with a very large cage, which is open all over the place, right? So we try to give it as most free field as possible. And now the little things make the difference. Every microphone has electronics in the bottom, right? So if you look at that, you would have a reflection from the body where the electronic sits to the capsule. What is it, about 2.5 centimeters? So that would cause reflections in the way of 6.5 kilohertz. Now, if you look at this microphone, you see at the bottom, there is a diffuser.
Oh, yep, I see it.
Can you see that?
I do.
So this is not a hard body, but there is like a mesh grill at the bottom, leading the reflections to the body and not back to the capsule.
So you literally have a diffuser that opens up below this capsule,
Exactly.
specifically to help the region that I was just talking about.
Exactly.
Other microphones sounding shitty in. So, this diffuser, you said is tuned to 6.5 kilohertz, and that harsh 7K that's coming through a bunch of other, there's a reason why these microphones sound great. And I think the more and more I'm spending with you, I can tell it's because you guys care.
We do.
And that's awesome to see, man.
And you see it in the handhelds.
Yep.
Why is the capsule sitting so far away from the body?
Because it's suspended, right?
It's suspended and it gives little reflections to the capsule because we try to give it even around the capsule an open space.
Oh, interesting.
Again, open as possible. Can you do a free field in a handheld? You can't, but that's the best you can.
So how does the open concept work in something like this?
Because it's also opened on the rear side of here, but obviously we only have the openness on all the sides and on the top. We couldn't do it on the bottom because then you don't have a pencil mic anymore.
Absolutely.
But that's also why this is not called OC but CC.
CC. Okay.
OC stands for open condenser.
Okay.
OD for open dynamics. So everywhere we have the OC and OD, we try to imitate the best free field acoustic you can have.
Okay. And then CC, does that stand for closed condenser then?
Yes.
Okay, very cool. Well, thank you so much, man.
Thank you very much.
So we are here at AES 2025 with our new friend Russell from Eventide, and tell us about Temperance.
Okay, Temperance is Temperance Pro. We just launched today.
Yep.
We gave a free one out called Temperance Lite. So, if you're not ready for the Pro, go grab the Lite, try it out. But yeah, Temperance is the world's most musical reverb. You can see it's all built around this center control here. And basically we find the notes in the room. We can analyze the reverb space and we know what parts of the room are musical, and we can either turn this temper knob up to emphasize those notes, right? And you can select the notes, right? You can pick which ones you want, or we can turn it down to de-emphasize. So you could do something like turn a percussion or drum track into like an ambient pad. You can sequence that. We have a sequence mode. Or for like mixing tasks, you can do some unmasking in your reverb. If you turn the other way, you want to de-emphasize those notes, make some space for the music that's kind of keep that in scale space going, right?
So, but you can ultimately, what it sounds like is you're saying that you can pick the notes of the key of your song and
Yes.
have your reverb actually play along with it.
The reverb can play along with the notes. The reverb, you can emphasize the notes, you can de-emphasize the notes. There's different reasons you want to do one or the other. You can actually also, if you see this thing here, obviously this is not going to change color because this is just a sign, but you can target the early section of the reverb, the full reverb, or the late section of the reverb for where you want those notes to happen. So not only like what notes, when notes.
So you could have it start at one note and shift into another note.
You could do that with the sequencer.
Okay.
But in this case, when we talk about the early part of the reverb, we're talking about like the very first reflections. Yeah. Right. So you can have you can basically like get like a really subtle kind of sequence or note sound in the early field, or you can have it kind of bloom shimmery in the late field.
So a tool like this, I clearly can see a use in music production, but would you say that this also has a very big use in something like sound design?
Oh, absolutely.
Yeah.
We don't know yet. We tend to put out the tools.
Yep.
And then people use them in unexpected ways, and we're like, "Oh wow, I didn't think of that. It's amazing."
So you said, before we started this interview, that you've been over at Eventide for 17 years.
Yes.
So what do you primarily do over there?
I'm the Chief Technology Officer.
Oh, dang, you're the CTO.
I'm the CTO. Yeah.
Okay. Hey, so you are kind of pushing, you're moving Eventide forward.
Moving it forward. Yeah.
Okay, so are products like the H90 and the H9, are those things that you?
Yeah, I did a lot of algorithms in DSP in the H9. The H90 was one I owned. I designed that and led the team.
Yep.
To do the H90. It was kind of weird. It was one of the first projects that I completely owned but didn't write any code for. It was strange.
So when did you take on the CTO role then?
That was probably at the tail end of H90.
Okay.
I was working on H90 and split EQ filter design at the same time.
Okay.
I was leading H90 and then still doing signal processing engineering. This is built on something called a modal reverb.
And that's what's on the other side here, right?
No, on the other side,
Okay.
those are our immersive plugins. So
Okay.
we've taken some popular Eventide sounds and made them 3D.
Okay.
Black hole and micro pitch.
Yep.
This is an entirely new way of thinking about reverb in the modal domain, because you can basically we have algorithmic reverbs, which we program and use things like feedback delay networks, and we have convolution reverbs, which we all know about, right? Where you go to a real space and shoot an impulse response, and to us electrical engineers, it's like, oh, that's kind of the basic definition that you can convolve something, but
Yep.
this is something different. This models a room. as a series of resonators, like thousands and thousands of filters running in parallel, additively combined to make it sound like maybe a real space, a fake space, it's whatever you want. So we have some machine learning by which we can take impulse responses and turn them into modal responses.
I can see it. I can see it in my brain. So you take the impulse response, and then you train the resonators based.
Yes.
But since they're resonators, at that point you then have full control over.
We have full control.
Which
We know where the notes are.
we know where the notes are
Yeah.
based on the pitches.
Yes, exactly.
Fuck yeah. Smart man here. Very smart man. So is this a concept that you developed yourself, or is this a concept that someone on your team?
So modal reverb is, any type of resonance-based sort of composition of a space or any sound has been around for a long time. We've known about it academically for a while. One of the interns we hired in 2014, he interned in 2014 and then we hired him. His name is Woody Herman. He's a senior DSP engineer. He's been the one developing this for over 10 years. We're always working on like 5 things at a time. This is one of the things he's been working on. And then him and a whole team of other people have been and then another guy named Corey Karalik led the R&D for the machine learning part of this, like where we can capture these sounds, and Woody did a lot of the synthesis part, like actually realizing them musically.
That's very cool. Yeah. Well, thank you so much.
Hey, you're welcome.
So were you involved in things like the Omnipressor reissue and the H9000 as well?
Not Omnipressor as much, outside of just giving feedback. I'm not really a hardware engineer. H9000, yeah, I probably, over the course of my career, I ported most of our signal processing code to C++. And mostly so we could get it on the H9000, which is running ARM processors.
Okay, very cool. So you not only as the CTO are a visionary of what you guys are trying to push forward, but you can you roll your fucking sleeves up in straight code C++ and get an algorithm going on that box.
Oh yeah. It's actually really easy to write algorithms for that box now. We have a really cool, the team that makes our internal SDKs, really, it's so fun.
Okay.
Yeah.
Very cool. Well, I just want to say thank you so much for your time today.
Yeah, you're welcome.
We've been thinking about you. I know we've been gone, but what have you been doing this year?
What have I been doing this year? A lot of interesting technologies at Sony. As product manager, I support a lot of pro audio products, including all of our studio microphones, our classic C800G, all of our high-res mics that all go out to 50K, our really incredible value, the C80, the little brother to the 800G, which is my favorite microphone, our open back headphones, the MDR MV1s, which I love, have never loved pair of headphones. People wear them, it's like wearing air, it's like wearing whipped cream.
So is this like the new 7506 thing?
It's not, because these are open back headphones. Okay. These were designed to go along with our 360 virtual mixing environment technology, where we capture each person's very specific head-related transfer function, how sound reaches inside their ear canals, related to the sound of the room you're in and all that stuff, and then can reproduce it on a laptop and a pair of headphones.
And so that was what you guys were doing at NAMM.
That's right, exactly.
So will you be doing that again this year?
Well, of course.
Okay.
But these headphones, as an open back headphone, were designed to complement that, but not only be used in that application. But closed back headphones like a 7506, or like the 7506's newer version, which is the MDR M1, with a wider frequency response of 5 hertz to 80K, all that kind of stuff. Closed back headphones, you can say, build up resonances inside the earphone that hurt localization cues. And if you're trying to do the 360 VME of reproducing in headphones the sound of an actual room and up to 16 speakers in any location, all that stuff, an open back headphone is best to do that. But open back headphones leak low frequency information out, and that's a problem. So a lot of open back headphones can sound very nice, but they're kind of really wimpy on the low frequency. So we redesigned the diaphragm that can handle as low as 5 hertz, but all the way up to 80K. That's a very hard thing to do. The center of the diaphragm is stiff enough to do 80K, but the outer edge of the diaphragm has to be pliable enough to do the 5 hertz business, right? But that's where you instantly get low frequency distortion as soon as you turn up the headphones. So you have to prevent that from happening. And we came up with a new approach to do it. We took what are called corrugated lines, but we made them curved corrugated. You see the curved lines. That makes for even longer corrugations, and also the curvature of it helps reduce that distortion. So now we can get a really lot of low frequency without distortion. But if you have a lot of low frequency, but it's mushy, and that's a technical term, mushy, it's no good. So what we design on the back of the diaphragm that faces out is something called a tri-duct structure. 3 little posts, very specifically sized with very specific size holes in them that act as acoustic resistors, control the volume, flow, and velocity of air going in and out of the diaphragm structure in reaction to that low frequency. And that keeps the low frequency very tight, and even specifically around the 200 hertz range, which is problematic for male vocals, where it can get a little bit mushy. So it keeps the low frequency very, very tight. And that's some of the magic behind the MV1 headphones. But they are stupid lightweight. They are crazy lightweight. You can wear them for 12 hours a day, and you forget you're wearing them. It's kind of like wearing your favorite pair of jeans. You're not always running around going, I'm wearing jeans, I'm wearing jeans. They're just part of you. So are these headphones. They are so light, but they're not plasticky. These are as a special aluminum alloy, and we had to find a way to drill all these holes individually. We took also the weight of every piece of the headphone, reduced it in 1/10 of a gram increments, just up to the point that if we made them any lighter, they wouldn't be strong enough to stand up to a professional application. We even put in the ear pad material is called Alcantara, which is what they use in luxury sports car seats. So when you're going around a hairpin turn at 90 miles an hour, you don't go sliding out of your seat. And put them on real quick, just to feel how light and comfortable they are.
No, they're incredibly light. Like, I mean, compared to, these are the 7506s, right? Which
those are the 7506s.
I mean, they're half as,
Actually, they're very light. They're
No, but I would say that those are probably half as.
Those are 223 grams if you're keeping track.
Okay.
But anyway, so that's that's a bit of headphone land for us, and a little bit of VME land.
So can we circle back here? You just said that this microphone, the C80, was your favorite microphone.
It is.
Okay, and before we started the whole camera, we got into a little bit about the C48 and the history of this. So tell me about the history of the
800?
Yeah, give me the 30-second history on this, and then why is the 80 your new favorite?
Okay, let's move a little bit this way, if you don't mind.
Yeah, no worries. We're gonna just...
Many people don't know that in Sony's history, Sony came in as a company in the 1950.
Yep.
And the name Sony is even derived from the Latin word sonus, for sound.
Oh.
So that was the first thing. Our very first product as a company was a reel-to-reel tape recorder that we sold to schools so that musicians and singers could capture their performances, listen back, and do a self-critique. So audio is as deep as it can possibly be in the history of Sony. But our very first product being a reel-to-reel tape recorder, what good is a tape recorder unless it's got an input device? So we had to make our very first microphone. That's why we made our own tape and the whole routine. But we started making microphones in 1950. We then improved them, got better and better, and we ended up coming out with our first serious pro microphone called a C37, which if you Wikipedia, you will find out it became Frank Sinatra's favorite microphone. Here he was singing and recording at Capitol Records building in Hollywood with a live orchestra, direct to disc, and he kept stopping the take, as the legend goes, because he didn't like the way the sound of his vocal came back. Somebody said this little company, Sony's got a brand new tube condenser style microphone. He fell in love with it, ended up even buying them to take out on the road to sing live. But so we started investing in developing professional recording microphones, the C37 being really a very important thing. Years later, we came out with a C48, and then the most iconic one we make is the C800G. And the C800G we came out with in about 1990. It was designed because we were at the heyday of our introduction of true digital audio recording professional tools. The world is migrating from analog to digital multi-track, CD mastering, digital reverbs, digital consoles, all these things. But we also realized that unless you have an incredible microphone at the very front of that chain, all this stuff is nice, but you're kind of faking it if you're not using an incredible microphone. So we set upon to design the best microphone we could. And the idea is we wanted to make a tube microphone because people appreciate the even order harmonic structure that you get out of tube electronics. Of course, our engineers go out, as they many times do, and they bought all the other competing existing tube microphones on the market, and they set out to test them. But what they found out immediately is that they spec'd differently every single day they tested them, based on largely the temperature of the studio, the resultant temperature of the tube on board, and that has a big impact on the noise floor of the mic as well as the sonic character. If there's one thing a Sony engineer hates, is not having a Sony product be absolutely perfect every time you use it and wherever you use it. So, they found that if we keep our tube inside the C800G at exactly 13 degrees Celsius or low 50s Fahrenheit, you get the quietest spec, the best sonic character of the microphone. But how are you going to regulate the temperature of a hot glowing tube? You can't dunk it in a bucket of water and you can't blow an air conditioner on it. So they had to come up with a different method of effectively cooling it and controlling the temperature. And they found a semiconductor device back in 1990. We didn't invent it, but it's called a Peltier device, P-E-L-T-I-E-R. Weird semiconductor chip because one side gets hot, like chips usually do, but the other side gets cold. And now you lay the tube next to the cold side with some thermal grease in between to add conductivity, and now you can regulate the temperature of the tube. The tube is in this housing right here. Take one of your fingers and put it on the top of the housing and one on the bottom. Top's a little warm and bottom is
Cold.
cold.
Yep.
That's where we control the temperature of the tube. Now, that's crazy enough as it is, but it's not as crazy as it gets. We have the heat sink on the back of the microphone. Hopefully the camera can see it from the
We'll grab
side.
some B-roll.
Good. So the heat sink is there, but how is the heat going to get from the tube area out to the heat sink? It's not going to go there on its own because it happens to be close by. So they had to come up with a liquid transfer mechanism to get the heat from the tube out to the heat sink. How are you going to do that? They built something called a heat pipe, which is a hollow pipe closed at both ends, filled with a fluid whose boiling point is at the temperature of the hot tube. Because what happens when you boil water, it changes state into a gas, into steam. Same thing is going on inside of this hollow pipe. We're creating hot gas bubbles that float up and out to the end of the heat sink, release their heat to the fins, condense back into a liquid form, and dribble back down to the tube area where they get heated up again, and they go round and around all day long, keeping the tube at the perfect temperature. So it's a thermoelectrically liquid-cooled, large condenser tube microphone. They also went another step further in realizing that the job of a microphone is to have just the diaphragm react to the pressure waves in air. However, those same sound waves impinge or hit the body of the microphone and can cause that to vibrate. And if that vibration also makes its way into the diaphragm, it can muddy up the sound. So they realized that different metals have different resonant frequencies, and they built the top half and the bottom half of the body of the microphone out of two dissimilar types of metal, because at the transition point, that vibration is shunted because of the different resonant frequencies. So these are what Sony engineers do. They look at common issues and they come up with creative ways of solving those problems. However, all this stuff is fascinating, right? It's nice to know the tech that's going on here. And whenever you use this microphone, whether it's inverted or not, makes no difference. But you want to make sure that the heat sink is either completely horizontal or, even better yet, elevated by a couple of degrees like we have it here, so the gas bubbles float up and out. You don't want it angled down because you think it looks cool, because the gas bubbles will stay trapped at the heat sink, at the tube area. However, what's really important here, not the tech, it's how does the mic sound. Right, Wes? Right. So the idea is why this mic became popular is because of a characteristic called forward voicing. Forward voicing is when you've captured that perfect vocal take, and now you bring everything else up in the mix, but all of a sudden the vocal, even though it's loud enough, it's not sitting out in front. And the vocal is the most important thing. It's got to be out there. So your inclination is, oh, I'll take my vocal track and I'll send it through some plugins and try to make it have its own voice again. The C800G has a reputation for pre-voicing it for you, where it keeps it out in front of the mix without having to hurt it by going through plugins. And that's what people really love about the microphone. However, this all comes at a cost. No surprise. When we introduced this microphone back in 1990, it was, I think, $5,600, $6,500, somewhere around there. Over the years, it's gone up and up and up in price, but it's a lot of years we're talking about. And today, this microphone is $16,999. So it's kind of an expensive microphone, but if you're a professional studio, you will have a lot of customers that demand this microphone. And if you don't have it, they may not come to your studio. So that's a problem. And for many years, we were very back-ordered, a couple of years back-ordered on this microphone. We are catching up with it, and we added production capacity, but they're hand-built in Japan by little gentlemen that have been hand-building them for 30 years. And, you know, care about the direction of the screw heads, everything, everything, everything. Actually, it's an interesting story. We made a video about the factory it was made in, and I had it translated into English by one of my Japanese colleagues. And one of the things that the guy said is, I only cut my fingernails on the weekends because I like the extra sensitivity I get out of a slightly long fingernail while building this microphone during the week. This is the Japanese mentality of building and craftsmanship. The diaphragms are made in a clean room. You got the idea.
Absolutely. I'd love to see this video.
It's online. It's online. Okay, look up Sony C100. Now, again, if you're a rock star or a commercial studio, you have to you should buy this microphone.
And we own this microphone.
Terrific, yes. Terrific. And now you know what's going on inside of it if you didn't already know. But there's a lot of people out there that can't drop that kind of coin on a fancy microphone. So we introduced the C800's little brother, the 800's little brother, the C80. And that's this microphone. It's not a tube microphone, but it is voiced to sound identical to the C800G for a very reasonable price. Okay. It's cardioid only. It's a double-sided diaphragm that reduces proximity effect for people that don't really know how to work a microphone so well. The diaphragms are also made in a clean room. It's a double metallic structure, pad, filter, all of that kind of stuff. It's a keeper. It becomes a permanent part of your collection instead of starting out buying a knockoff microphone and then putting it in a drawer as you build your collection.
And the one thing that I know about this microphone, what I remember when I saw it come into the market, it's very reasonably priced. It's around $500.
$549 currently as of a recent price increase. And here we've got both microphones going through a lovely little Allen and Heath CQ18T, digital mixer with 96K converters and great mic pre's and all. And yes, it's a trade show, it's a little noisy, but you go back and forth these microphones and you can't tell the difference. So you won't be able to hear that, but here you can, and you can attest to it.
Okay, and before we let you go,
yes,
there's a couple other microphones up here.
Yes.
We got the
C100.
And this is something that I've always been excited about because there's not too many microphones that are out like this.
There aren't any.
A dual diaphragm condenser microphone. And I'm a huge fan of dual diaphragm. There's a microphone called the AKG D224. Do you know that microphone?
Yes.
Yeah, so it, dual diaphragm. But
two small diaphragms, right?
In a dynamic, but this is a dual diaphragm condenser.
With a large diaphragm and condenser, a large diaphragm and a small diaphragm. So the large diaphragm captures the body of things we want to capture the body of. And then it's designed to capture from 20 hertz to 25K. And the backplate design of that large diaphragm is designed to naturally roll off the response of that diaphragm to 25K. At which point, the small diaphragm takes over and goes from 25K to 50K. So we do all this without a potentially damaging crossover, which we wouldn't want in a microphone.
Okay, so there's no electronic crossover.
No, but this goes out to 50K. In our two pencil microphones, we have an ECM 100U for unidirectional or cardioid and a 100N for non-directional or omni. Those have just the small diaphragm, but in those, we run them full range from 20 hertz to 50K.
Okay.
So the point is, why 50K? I'm not a bat, I'm not a dog. People always, can start thinking that. But the point is, professional microphones, or many microphones that are a spec has 20 to 20K, they really start rolling off around 12. And there's a lot of acoustic instruments that have a lot of energy well above and out further. The soundboard off of a grand piano, fresh acoustic guitar strings,
The harmonics on a
cymbals,
triangle.
exactly. All that is really there. And these mics, because they go out to 50K, they're picking up all of that stuff. So that's an important reason. But also for the people that are really into it, these have an ability with a phase response that is moved way out high. So within our normal hearing range, all of the frequencies are time coincident. They're not they're not delayed and time smeared and things like that. So that's an important thing. Also, if you happen to be a sound designer and you're trying to capture, the sound of a blender and then slow it down to make a spaceship sound, if you capture it at 48K and then slow it down, all your high frequency is gone. Here you can use a 50K microphone, any of them, crank up your sample rate to 192 and then slow it down, you got tons of high frequency left.
That's very cool.
These pencils are great for a lot of applications. A pair of the cardioids in an ORTF over the soundboard of the piano is the most intimate sound of a grand piano I've ever heard. Obviously you can do a Bloomline pair outside, all these other kind of ways, high, low, so on and so forth, but that is my favorite. On drums, the cardioid pencil, I've heard so many people say that's the most incredible hi-hat mic I've ever heard. We've got a famous drummer who is just now using C80s on his floor toms and a pair of C100s 3 or 4 feet out in front of the kit, as well as a pair of Omnis over the kit to get the picture.
An Omni from these?
Those, exactly. And he is just flipped out. And this is, I won't mention him by name because I don't have his permission to, but a very famous session drummer for many years. Anyway, that's kind of where we are in microphone land.
Well, I love to see the enthusiasm. I love how excited you are.
Yeah. I couldn't be even more excited about, the C80. I just love that microphone. It's a ridiculous value. At Sony in my career, I've seen us come out with so many products, but usually they're, on the pricey side. There's a lot of R&D that goes into them, and they're worth it, but it's expensive. Once in a while, we come out with incredible products that are so ridiculously priced low. I go, are you sure? And they did that with both the C80 and the MDR MV1s. These are ridiculous values. So if you got a chance, go check them out.
Okay.
I think you'll be very happy you did.
Okay, well, thank you so much, Andy.
Thank you very much. Appreciate it.
Before we go, I want to tell everybody to make sure that they come to NAMM, go to the Sony booth, and get your HRTS done, because
It's called 360 VME. Go get profiled.
yeah, I think it's one of the coolest things that you can do at the NAMM show.
And you got to sign up early because there are a limited number of testing spots, profiling.
You guys have 3 months to get ready and prepared if you want to get it done, because you should.